Hi everyone, welcome to Cloud on Air. My name's Jay Jenkins and I'm a customer engineer based here in Singapore. Yesterday, Ashish Pillai told us where we should run our code. Today, Richard Coombs is going to tell us where we should store our data. Richard Coombs has been with Google for a number of years, previously with the Maps team, and now he's a customer engineer based here in Singapore. Remember that during this session, at any time, you can ask a question below, and we have technical experts ready to answer. So with that, I'll pass it to Richard.
Thanks for that great introduction, Jay. So yeah, I'm here to talk about Google Cloud storage options and the best place to store your data. So we're going to jump right in. So today, I'd like to try and cover three goals. First, provide a bit of a brief background on storage services, give a bit of context on how things fit together and the use cases that we see. Secondly, look at the storage solutions available on GCP or Google Cloud Platform, but also show reference architectures and use cases, how those storage solutions are used with other components. A storage solution really is never used in isolation. And finally, and probably most importantly, walk you through a decision tree. So it can often help. We've got a large portfolio of storage services, help with questions and answers, how to get to the best solution for your particular project. So as a start out with a little bit of background, so I've been in the IT industry for about 18 years. Jay mentioned that I'm a bit of a maps geek. Doesn't really matter where you're from or what part of IT you might be working in. Every project really is got storage at the heart of it. It's a fundamental part of every system. So over the years, though, we've seen a change in the use cases and the technologies and the design patterns associated with them. So I wanted to start by giving a bit of a brief background of those and how some of the technologies from GCP sort of marry up with them. So I'm going to start with the industries and use cases that we see. Now this is a pretty busy slide. There's lots of examples here, and hopefully you can see sort of your industry and use case mentioned. But the thing that really jumps out for me is no matter what industry you're in, you should really be a data organization, as well as your core focus as well. Because data, at the end of the day, is the lifeblood of how a business is operating. You'll want to be running analytics on that data. That's going to give you a competitive advantage, take your business in new directions. With new technology and capabilities that the cloud offers, you can be running your industries much more efficiently, helping disrupt things, and really even making new businesses out of it. I think one great example that illustrates this is Rolls-Royce. So Rolls-Royce is a company that produces airline engines, amongst other things. So if you ever sit near a window on a plane, you look out and you can see the RR logo on the engine. The interesting thing is Rolls-Royce don't actually sell their engines, they lease them to the airlines. What this does is allow them to collect lots of data, lots of telemetry information, and do analytics on it. And this gives them huge insight into how those engines are running. This means they can do predictive maintenance, understand whether they should repair versus replace parts. And this is providing a much better service to their end customer. Run the engine much longer and make it more efficient. And all this data and this information is going to go into their subsequent products. So the next generation of their engines are going to be based on this information. Try to think of the next iteration of your product without having any knowledge of what's happened in the past. So I also want to talk a little bit about the customer journeys we see, how people are moving to the cloud. And this is born out of speaking to developers, managers, CTOs, CIOs like yourselves. Everyone is thinking about the cloud and how to move to the cloud. And I think everyone realizes there's so many benefits, whether it's cost savings, more flexibility, better security. But we see these journeys roughly breaking down into three major areas. And they definitely overlap. There's no fixed line between them. The first sort of journey is really with companies who are still mostly on-premise, and they're really only using the cloud in a limited way. They might use one aspect of their overall architecture in the cloud, something like backup and archive of cold or static data. A second one could be burst compute. They have a new project coming up. They don't want to they want to avoid capital investment, so they'll effectively rent space in the cloud and run things there. But these companies are really just dipping their toe into the cloud. Secondly, we've then got companies who are moving a significant portion of their applications to the cloud. This means they've got the ability to scale with larger virtual machines. They can scale up their databases. But it's really the same profile that they've been used to, now just operating slightly differently. So this is a so-called lift and shift. But really, when they're in the cloud, they realize they can do quite a bit more. They can generate more data. They've got more compute power to process it. This is where they start looking at managed services. They don't want to be running clusters of thousands of VMs and managing Hadoop infrastructure. They really want to be focusing on the business rather than managing that infrastructure. So that sort of process can be seen as sort of the move and improve, really starting to take advantage of some of the benefits. And then the third journey is sort of apps built net new in the cloud. These are cloud native companies. There's no legacy infrastructure, no limitations. It's much faster time to business value. So that's a look at some of the common journeys and use cases. I'll now sort of move on to the evolution of storage and data. So with the evolution of storage, we really start with direct attached storage. This is where we have physical disks and physical computer sort of in the same machine. This could be the laptop you're watching this on, or the box underneath your desk. This is where we have compute and storage together. But enterprises really evolved into using storage area networks, or SANs, as well as NASes, or network attached storage. And the fundamental difference here is this separated compute from storage. This really allows much better control over each of those. So you can set different policies of how both are provisioned. Dial one up if you need more storage on a particular project, same with compute. So SANs and NASes have really been the building blocks of enterprise storage. And you can see across the bottom there that Cloud Platform can sort of meet you there as well. So local SSDs will sit sort of in the same rack as the compute. So that's synonymous with the direct attached storage. And then if you need sort of the block storage with SANs or NASes, then you can attach persistent disks to your compute. But that storage is really coming over the network. Then as we get over to the far right is object storage. Object storage is more recent. We see that most enterprises are not running this themselves. They'll typically be using a cloud provider to do this. And object storage allows you to store large amounts of unstructured data, blobs or files, things like that. So that's the evolution of storage. Now let's move on to have a look at database and analytics. So starting on the left with the relational database, I think this is probably very familiar to most of you. It's well known. It's been around for a while. It allows you to store your structured transactional data. So you've got your well-defined schemas. So if you've got a few of those in your organization, you can use ETL, or extract, transform, and load, to pull that data out and push it into a data warehouse. So you've got potentially multiple databases all feeding into your data warehouse, allowing you to answer questions like, what's my sales by region or by rep? And sort of this, I said this is well established. We had players like IBM, Oracle, Microsoft providing fantastic software in this space for many years. So a long time goes past, data volumes grow. This was in the rise of the so-called big data phenomenon. And we needed a way to process and manage unstructured data. So new technology like MapReduce and products like Hadoop came on the scene. So you couldn't really be storing that kind of data in relational databases. So because of that, specialist forms of stores started to emerge. So what happens if I've got semi-structured data? It's got some structure to it, but I can't really put it into a relational database. So a good example of this would be a telco. So they've got lots of cell towers, lots of information flowing through those cell towers, capturing lots of data. But you might have different software versions or by different software vendors. So you kind of know what it looks like, but it might change over time. The columns associated with that data might change over time. So this was the rise of the so-called NoSQL database. And there's two main flavors of NoSQL. First, you've got your wide column database, so your sort of key value. And secondly, your document-based or hierarchical NoSQL database. So this is things like your JSON documents, so your JavaScript object notation data, or other data typically coming from mobile in that sort of document format. Then on the far right, we've kind of now getting into a new area of data storage with databases. I've seen this termed NewSQL. This is where you've got a relational data structure, but it allows you to do horizontal scalability and maintain consistency. So typically you could only scale up rather than out, and I'll touch on that a little bit later. So on this slide you can see across the bottom we've got Google's offering from Cloud Platform, and I'll be diving into each of those products as well. Okay, so next I'd like to kind of really go into each of those products, and I mentioned before, give a reference architecture and a use case, how those products fit into an overall architecture. So first up, we've got cloud storage. So Google Cloud Storage, or GCS, is our managed object storage service. As you'd expect by the name, this is for storing objects in the cloud. So this unstructured data, files, and blobs. GCS comes in 4 sort of flavors. We've got multi-regional, regional, nearline, and cold line. And I'll describe kind of what those are best used for. We see those really matching the different use cases for GCS. Things like content storage and delivery, analytics and machine learning, and backup and archival. So one of the great things about GCS is you've got a consistent API and performance across all of those tiers. You've got millisecond latency, the same time to first byte, and great throughput. It's really about how hot or cold your data is, how often you need to access it. With GCS in multi-regional mode, we've got very high availability, so 99.95% uptime. So the example here that I'd like to pull out for cloud storage is around content storage and delivery. We see this as a very typical use case. So Google has 7 products which have over 1 billion users that often all of them require really, really fast serving of content. So things like Maps, YouTube, Chrome, Android, Gmail, for example. So those products and GCS are all built on top of the same same network. So it's using the same network and infrastructure. So a large percentage of the world's traffic actually runs across Google's network. We try and keep that traffic on our network as long as possible, pushed to the edge as close to the users as possible to keep things really fast. And we've got things like the high throughput connectivity and traffic optimizations to really help do that. So in this example, we're looking at, say, media files. So you've got a media company serving content globally. This could be images or videos. Could be as simple as just images in your app. So within GCS, you can tier your data on how hot or cold it is. So with lifecycle management, if you've got a brand new video, very popular, everyone around the world's accessing it, you obviously want to put that into sort of a multi-regional bucket. As that data ages, it typically gets accessed less and less, which is why you can then set a process to push it into different tiers of storage. So if you're accessing it less than a month, then you'd be putting into something like nearline, and then with cold line, you're accessing it less than once a year. So I mentioned that with GCS, we really try and push data to the edge of our network, close to where the users are accessing it. So in a way, it's acting like a very basic CDN. In this architecture, you can see we've got Google Cloud CDN. So that's Google's CDN product, as well as CDNs from our partners like Fastly, Akamai, and Highwinds. So those partners and a specific CDN product are really going to give you a lot more control over the caching policies, how and when those files are updated. So it gives you a lot more flexibility. Okay, moving on to sort of the database side of things. We'll start with Cloud SQL. So Cloud SQL is our managed service for third-party RDBMSs. So we support MySQL, and we recently announced support for Postgres, which as a Maps and GeoGeek, as Jay mentioned, is fantastic, because with PostGIS, it allows you to store, manage, and query your geospatial data. But we'll be adding support for more third-party databases over time. So with Cloud SQL, it's a fully managed service. So Google's going to do the patches, the updates, the auto backups, failover for you. That means you can focus on your business and we'll act as the DBA. So you have the choice. You can either run things as a single instance or with failover replicas with MySQL. So if you're running in high availability mode, you're going to get an SLA of 99.95%. It's probably important to say that these SLA numbers are very important to Google. Putting guarantees behind our products are important, so you'll see those going through these slides as well. So a good example of how people are using Cloud SQL is with e-commerce. So here's a fairly common architecture. You might be running App Engine or Compute Engine as your sort of application layer. This could be WordPress or Drupal or something. Then at the database level here, you can see that we're running in high availability mode. We have a failover replica, which means if the master node fails, then it will automatically fail over to that replica. Also here, we're using a read replica. So this is where you can shard your reads and writes. That means if you're getting close to capacity on your master node, and you've got other things reading from it, so here we've got our BI tools like Tableau, Looker, and iCharts, you can split those workloads. So you're not going to be impacting the database performance for your customers by doing some heavy BI work on the back end. So great that you can provide those read replicas. So next we've got Cloud Spanner. I think this is a really exciting product. So it's a managed relational database service. It's pretty new. I think we announced it in mid-February. Here you're really getting the best of both worlds. In the past, what you had to make a decision with is if your data started out growing your relational database, you either had to start sharding it or move into a NoSQL style of database. With Cloud Spanner, you don't really have to make that trade-off. With Cloud Spanner, it's horizontally scalable. So with traditional RDBMSs, you could only scale up, which means put it on a bigger and bigger box, more RAM, CPU, and then start sharding if you reach that capacity. With Cloud Spanner, you've got horizontal scalability, which is where we're running it across more and more machines. So effectively, you can scale to any size. This has been possible through Google's superfast network, where we're utilizing GPS timing and atomic clocks in our data centers, all very clever stuff. There's a fantastic white paper if you really want to sort of geek out and understand how it's done. With Cloud Spanner, it's great because you can start small and just add nodes as your data grows. So if you think you're going to be reaching a limit on your database and you're going to need to start sharding, definitely take a look at Cloud Spanner. And because we've got that horizontal scalability, there's no downtime for failovers, no patching, etc. required. Because of the different style of architecture with Spanner, it means we can offer very high availability. So at the moment, we've got a 99.99, so that's 4 nines of availability. Later this year, we'll be offering a multi-region version of Cloud Spanner, which can give you 5 nines of availability, which by my calculations gives you 26 seconds of potential downtime, which is pretty amazing. So a good use case for Cloud Spanner is where transactions are very important. So Cloud Spanner will do strong consistency. So if you're in a system where being off by 1 really matters, you've got 10 of something, but then you try to sell 11, you're going to have a bad time, right? So we're seeing good, strong adoption of Cloud Spanner in our early access program, which has been open for more than a year. Now everyone can use it in beta. In this example, we're looking at supply chain. So typically you might have different databases covering different parts of your overall supply chain in your business. So on the right-hand side, we've got, as your products are being built, parts being delivered, you're managing that in a supply chain application. Here we're using Cloud Spanner as the ledger. That's the single source of truth. No separate systems for part deliveries and vendors and assembled products and things. Once a product's been assembled and made, typically we would then go into an inventory system. But here, again, you're using a single source of truth, so you know that you're not going to get inconsistencies. So Spanner is really an application database, but you can also do analytics on it. Because you've got that horizontal scalability, no need to do read replicas. You can point your BI tools at it and really start interrogating your data. So next we move on to Cloud Data Store, which is our managed NoSQL document database service. So Data Store used to be part of App Engine, is now a standalone service. And it's really designed for mobile or web solutions. The reason that is it's optimized for those scenarios because of the auto-scaling and auto-replication that's done for you. So typically we see if your mobile app or web app is consuming or producing lots of JSON data, Cloud Data Store is a fantastic solution for you because of this document-based format. There's no provisioning or capacity planning up front. Start small, throw your data at it, and it will grow. So it doesn't matter if you're starting with 10 users, 100, or 1 million users, you can just get off and running. So I'm sure you've all heard of Pokemon Go. It's a great use case and showcase of how Data Store can really scale to meet any needs. So by default, Data Store is multi-regional, which is going to give you that high availability SLA of 99.95%. We do offer a regional version as well. So Data Store mobile gaming is a sweet spot, but really any mobile application. So I already mentioned Pokemon Go. Other customers like Snapchat really use Data Store quite heavily. So it's great to use as an application database. So in this architecture, you can see it's all about scalability. So on the right-hand side, we've got our network load balancer. This is a global load balancer. I think we probably don't talk about this enough. This is not a virtual machine running in your project. This is a global load balancer happening at the edge, which means there's no regional dependencies. You can load balancer across regions. Behind the load balancer, we've got a cluster of container engine machines. So here, this is managing sort of the game state for a player. Again, talking to Data Store. So this is what's happening with that player, maintaining the state of it. Further on the back side of this, then we've got again another cluster of containers managing the world state of that game. So what are other players doing? What's happening within that game world at that particular time? But they're all talking to the same Data Store instance, which means it really keeps the architecture very simple, easy to deploy and scale as well. Okay, now we're moving on to the Firebase side of things. So a couple of years ago, Firebase was acquired by Google. Since then, it's expanded considerably to now be our mobile development platform. So part of that platform is a Firebase real-time database. I think the real strength of Firebase is in the number of services it provides to mobile developers, things like authentication and messaging, but it's also with the native SDKs that it provides. So it makes it very easy for mobile and app developers to target Android, iOS, and JavaScript. We do a lot of the painful work behind the scenes for you. The real-time database also handles offline access. So if your users are going to be in a spotty network, connection dropping and coming back, then this really provides all of the fiddly things in the background to help synchronize that data when they come back online, as well as real-time synchronization. So if you do have a strong connection, it's syncing data to the app as well as to the cloud. So a good example of that scenario is around a messaging app. So here you can really see that the the beauty of this is the simplicity. Firebase is very quick to develop against. So if you've got that messaging app, you're on a train going through a tunnel, you still want to get the messages that you have tried to send or receive to arrive in your app, and it will handle that for you. So it's really all about taking those Firebase SDKs and integrating them into the app to do that sync of the data. One of the other things to mention with Firebase is analytics. So it will track demographics, retention, engagement, and custom events specific to your app. Now we also provide a link to BigQuery, which I'll mention soon. It allows you to do a daily export of data, push that raw data to BigQuery. Means you can then start doing, looking at aggregate data, not just from your mobile app, but other sources of data across your business, and really trying to get that overall picture. So next up, we've got Cloud Bigtable. So Bigtable is our massively scalable, wide column analytics database service. The core strength here is large analytical and operational workloads. And Bigtable actually powers many core Google services as well, things like search, analytics, maps, and Gmail. Somebody actually told me that we keep a copy of the internet in Bigtable, which kind of blows my mind, but kind of makes sense as things are updating on the web and we need to provide that information through our search service. Bigtable is providing that super fast way to do that. In cloud, we want to be open, so we've created the HBase compatible client library, which means you can really seamlessly copy your data from your HBase clusters, push it into to Bigtable, and that allows you to go from a self-managed service to a fully managed service, really kind of freeing up your time to focus on the data rather than running the infrastructure. I think the real power of Bigtable is the super low latency. So you're going to get single digits millisecond reads and writes, very fast table scans to really quickly be able to find that metric you're looking for. Also, we'll do very fast mutations or updates to data. So currently, Bigtable is a zonal service, so it's got a 99.5% availability SLA. A great use case for Bigtable is IoT, so Internet of Things. This is lots of devices generating lots of data, all sending information into the cloud. So think of the example before with Rolls-Royce with all that telemetry data, sending data in to be analyzed. So sensor information from sensors or event data from mobile devices. Sort of the gateway for all that information, you can see in this architecture is Cloud PubSub, which is our messaging queue service. So PubSub stands for Publish Subscribe. So you can have things like Cloud Dataproc and Cloud Dataflow subscribe to that information. PubSub really gives you a bit of resilience in your architecture. So if part of your system goes down, PubSub is there to sort of queue things up. So when things come back online, you haven't been hemorrhaging data. You can pick up sort of where you left off. So Dataproc's great for if you're running MapReduce or Spark jobs. Again, you can move that to a fully managed service with Dataproc. Dataflow is more around streaming. So if you've heard of the Apache Beam project, this is basically Dataflow is synonymous to that. So you can, again, run things. It's portable. Move what you're doing yourself and run things with Dataflow. So Bigtable really excels at writing and reading lots and lots of data. So it's good for time series data and mutations. And we recently announced BigQuery can now do federated queries into Bigtable. So if you need super fast reads and writes, fine, that's great. You should be using Bigtable. But if you want then all of the rich suite of BI tools, you can just point BigQuery directly at Bigtable, leave your data there, and start using those tools through BigQuery. Okay, now on to BigQuery. Speak of the devil. So I've mentioned it a couple of times in some of these reference architectures, and BigQuery is our managed analytics data warehouse system. So this isn't really where you want to be storing your transactional or live operational data. This is where you sort of push things to start doing lots of interrogation on it. This is one of the products we see that a lot of customers start with when moving to the cloud. They've got lots of data, but kind of don't know how to to start getting insight into it, BigQuery is one of those places to definitely start. And it will grow with your data. So you can start with a few gigabytes up to a few petabytes or even more. There's no provisioning capacity up front. You just define the schema, load your data, and off you go. You can be querying terabytes of data in a matter of seconds, even up to petabytes. The great thing with BigQuery is it supports ANSI SQL 2011 standard, which means you can connect lots of tools to it, your dashboarding and BI tools. Definitely check out our BigQuery technology partners page on our website. You could already be using one of those tools, and you can now put your data in the cloud and continue using those tools to get more insight. Finally, mentioning sort of SLA, BigQuery provides a 99.9% SLA. A great use case with BigQuery is all around logging. Here, this architecture is similar to the one we saw with Bigtable, but once you've done your batch streaming, batch or stream processing, and you want to throw things into your data warehouse, you don't need those super fast reads and writes. Then just chuck it into BigQuery. I think another good example here is of BigQuery. It gives you auto date partitioning. So as you've got data coming in over time associated with particular timestamps, BigQuery gives you those efficient ways to query data. I think another obvious one with logging is if you take your server log files, you can now just dump them into Google Cloud Storage and and use BigQuery again to do federated queries if you want to leave it there rather than importing into BigQuery, to use things like Tableau, Looker, and ClickQ to start interrogating that data. Okay, that's a lot of products I've just ran through. Hopefully you can see that we've got managed storage services to meet you for your use case. If we don't, you might be running a very bespoke or specific database. There's lots of tools to help you get that running on Google Compute Engine as well. So definitely have hopefully a solution that matches your storage requirements. Main thing is, how do we go about deciding? So as a quick recap, here is an overview of our storage and database portfolio. Now here I've left out persistent disks and Firebase, otherwise this slide was getting a bit too big. So we'll start on the left. I didn't really talk about in-memory storage, but if you're using App Engine, then Memcache really provides that fast in-memory storage that you'll need. Then looking at the relational side of things, we've got Cloud SQL. So if you're using a MySQL or Postgres database. Then we've got Cloud Spanner. So Cloud Spanner, as I mentioned, really gives you the horizontal scalability for your relational data and very high availability. So if you know you're going to outgrow a relational database, then Cloud Spanner is definitely where you should be looking at. Moving into the NoSQL or non-relational side of things, with Cloud Data Store, really good for sort of document-based data. So think of JSON files coming from mobile or web apps. Then we've got Cloud Bigtable, which is sort of our key value or wide column database for analytics. And we've got object storage, again for just storing blobs or files, unstructured data. And finally, on the far right, we've got BigQuery, which is our data warehouse. Interesting thing, BigQuery now is we can also access Google Drive files. So if you've got data stored in Sheets, you might want to be referencing that as you're doing pulling together your queries in BigQuery. So easy to pull data in from different locations. Okay, so now the all-important slide. How do you decide? So this sort of decision tree can help navigate through and narrow down what the best solution is. So I will start at the top and sort of walk through it. So is your data structured? We'll go to the left. If the answer is no, so it's unstructured, sort of file-based data, effectively it's going to end up in cloud storage. If you need mobile SDKs to help push that data through, then you'd be using Firebase storage. But actually, it's all cloud storage underneath. So back up to the top, is your data structured? Now we're going with yes, I've got some structure to it, maybe semi-structured or very structured. But is it an analytics workload? We'll kick off to the right, say, yep, I want to do analytics on it. Do you need to do super low latency and updates, very fast updates? If the answer is yes, then Bigtable is where you should start. If it's no, then our data warehouse product, BigQuery, is the right one. So back to the middle again, we've got our structured or semi-structured data. We aren't necessarily doing analytics workload on it at the moment. Next question is it relational? If it's yes, it's a strongly structured schema, it's going to be fixed, not lots of changes to it, then it's really all about scalability. If you know it's going to be a relatively small database, I say relatively small, could be still a few terabytes, then Cloud SQL, so either using MySQL or Postgres is the choice. If you do need that horizontal scalability, then Cloud Spanner is a good place to start. It's a good place to start anyway, because if you're going to grow. Then back to the middle. So let's say you've got that semi-structured data we talked about. It's not relational. Cloud Data Store is the place where you'd want to begin. If you need mobile SDKs to be doing all that integration and work on the background for you, then the Firebase real-time database is the answer, using those mobile SDKs to leverage that. So I think that is it. This is probably the screen that you want to be taking a screenshot of, or get your phones out and take a picture so you can refer to it later. I think with that, I will invite Jay back in. We're going to probably pause for a minute or two while we try and figure out the questions that we're going to cover in the Q&A. So yeah, just give us a minute or so. Thanks.
Great. Thanks so much, Richard. I know that I learned a lot, especially around that decision tree at the end, which I think is extremely valuable. I'd like to say to you, though, that at this time you might be seeing a little feedback form pop up on the side. Please provide us some feedback. Let us know if you like this session. Let us know what types of topics you'd like to cover in the future, so that we can make this better for you. So with that, I think as expected, a lot of the questions are around migration.
Yep.
Right. So how do I get my data in? How do I get my data out? So with that, if we use cloud storage as an example, how do I get my data into cloud storage?
Okay, with cloud storage, there's a number of options. I think most simply, you can use the web UI. Create a bucket, point to your file, your folder on your local machine, start uploading. Very simple. We've got the command line interface. So using those commands in the gsutil command line, typically we see that for on-premise data. So you might be coming from another cloud or on-premise. So using command line for on-premise data allows you to have multiple streams of data pushing into the cloud. It'll have the resilience. So if the connection drops or blips, it will pick up where it left off. You don't have to start from the beginning again. We also provide a transfer service. So if you are coming from another cloud provider, you can set up a transfer service. It might be a one-time thing, might be a recurring thing if you're running in a hybrid strategy. And finally, if you've got like a huge amount of data, hundreds of terabytes or petabytes, definitely come and speak to someone at Google or one of our partners, and we can talk about what is the best way to do that. Obviously, leveraging our partners as well, they can provide a service on your behalf, which it might be physically shipping disks to them and have them do it for you. So yeah, quite a few options.
Okay, awesome. And obviously a lot of interested in Cloud Spanner because it seems like it's a database that can kind of do everything. But if I have an existing relational database with a lot of data, how do I get that information into Cloud Spanner?
Sure. So with Cloud Spanner, unfortunately, it's not just take your relational database backup file and throw it in. There is some things you need to do in order to provide that horizontal scalability. We have something called interleaved tables. So what that is doing is basically taking data that is related to a parent table, let's say, and making sure that when you're saying it's interleaved, it's actually going to be on the same nodes close as possible, because we don't want to be querying data that might be very dispersed. That's going to slow things down. I mean, you don't have to do that, but it's really going to speed things up and optimize things. So yeah, it's a relational database, but unfortunately can't just take a snapshot of a MySQL, for example, and throw it in there.
Right. So
some work to do.
Yeah. So the person that actually asked that question, I did put a link in response to that question that provides you some more information around how you can efficiently migrate your data into Cloud Spanner. Also, on Friday, Win Wu is actually going to talk to us about Cloud Spanner in depth. So talking about what Cloud Spanner is, how it does things like interleaving, how we make that database globally efficient, globally scalable, and globally consistent, which is not an easy thing to do.
No.
So I think that will also help explain how we sort of take that cutting edge technology, make it available to you, but also how you can take what you're doing today and migrate that into Cloud Spanner.
Yep.
Great. So I guess the flip side of that, how do I then get my data out? So let's say that now I'm with Google Cloud today, but I need to bring my information back on premise for some reason.
Yep. Different for different services. So if I run through a few of them. So with GCS or cloud storage, you're not really locked into any specific database format. For example, it's just your image files, your video files, whatever they might be. So running a similar sort of process that you did to put them in, you're pulling them back out. With things like Cloud SQL, you can do an SQL dump file. You can export to CSV. So if you're maintaining it in, let's say, a MySQL database, you can use a SQL dump file and use that to sort of recreate your database somewhere else. If you're moving to a totally separate database, then a CSV approach would be better. With BigQuery, we provide, even through the web UI, you can say you want to export your data. You can do that through the command line as well. With BigQuery, we also have a number of different client libraries. So I think there's C#, Go, Java, PHP, Python, Node.js, Ruby. I'm sure I'm forgetting one or two in there. But if you want to create something yourself in terms of accessing it and pulling that out. What else? So with Bigtable, I think with Bigtable and Spanner, you'd probably want to be looking at data flow as the process to use. So I think the next session is going to be around big data and sort of processing. Really, you can use that same tool. So data flow allows us to do ETL, so extract, transform, and load. Really, you're just doing it in reverse, using that to pull data out and push it to wherever it needs to go.
Okay, great. And I guess going back to the other thing is also you can also rely on partners, right? There are a lot of partners that can help you with that as well.
Yep.
So I guess another thing that people need to be concerned about is whenever they're migrating just the data is also the applications. And I think this is one of the things that Google tries to do is we try to use a lot of open source interfaces.
Absolutely.
So for example, Bigtable using HBase. BigQuery supporting standard SQL, as well as a lot of other databases supporting standard SQL as well.
Yeah.
So again, something else to think about when you're migrating. It's not just about the data; it's also about the applications themselves.
Yeah. So it's a very good point with HBase. So I mentioned you can go from a self-managed to a fully managed. If you, for whatever reason, decide you want to reverse that, same technology will be there to help.
Awesome, great, thanks. So going back to BigQuery, because I know BigQuery is one of those sort of magical services where people don't even know what's going on underneath.
Sure.
And nor do a lot of our customers even care, right? We have people using petabytes of data that we've never even talked to.
Yep.
That are using BigQuery. But how do I connect with that? So how would I pull that information into a dashboard or into my application if I needed to?
Yeah, I think we've already touched a little bit on that answer. So I mentioned the client libraries across a number of different languages supported. You mentioned the ANSI SQL 2011 standard. So really, any tools that you can use that use SQL, that SQL standard, can be used to access that data. We obviously have the UI. So if you just want to get up and running and start tapping your queries in, you literally navigate to BigQuery and off you go.
Okay, great. I mean, I think BigQuery is one of those things you really have to sort of try to understand exactly how powerful it is. Yeah. I know that when Spotify moved over to BigQuery, they were absolutely amazed at how quickly they could just run an ad hoc SQL statement at BigQuery and not have to worry about indexes, not have to worry about optimizations, and BigQuery just did everything for them in the background.
Yep, I think if people really want to go and try and test it out, there's lots of fantastic public open source data sets available through BigQuery as well. So you can leverage these in your applications as well, or if you just want to have a play, very big data sets, things like Wikipedia is in there, New York taxi data sets are in there, weather information's in there. So lots of interesting stuff, huge data sets, but very easy to get up and running with.
Yeah, and I guess it's also important to remember if people are trying something that their first terabyte of queries is free.
I know.
Terabytes,
amazing.
A lot of data.
Yep.
So definitely give it a try. So finally, you mentioned a lot, I guess, about SLAs and the SLAs for the different services, and depending on whether they're multi-regional or regional. But what happens when we actually miss those SLAs? Like, what would happen if we missed an SLA?
So I guess the first thing to say there is, because there's different SLAs and SLOs, so service level objectives for all of our products, definitely go in and have a look at the the terms of service and all the documentation around it, so you understand what those are for each service, because they'll vary from one service to the other. I guess the main answer to the question is around financial credits. So if we miss that promise, then in your next monthly bill, you'll have financial credits that sort of provide sort of that monetary value back to you in your next bill.
Okay, awesome. Thanks a lot, Richard. And thank you all so much for your questions. Coming up in a couple of hours, talking about sort of data and where it's stored, Prakhar Gautam is actually going to talk about what you actually do with that data once it's there. So once I'm storing a petabyte of data, how do I actually process that? How do I make that actionable and get some actionable insight out of that? It's not too late to register. So again, I recommend that you take this, you forward it to your friends, you forward it to your colleagues, so that everybody can take part. And please continue to ask questions. We're really enjoying it. Also, there are a lot of questions around how I find out more information or how I learn about how to use these products. So on the screen, and thank you for joining, we've got some other things you can do. Number one is obviously getting certified. Quick Labs also has some hands-on labs, so you can actually use our tools. Coursera also has some labs. And of course, there's a free trial available. So there are actually free tiers for all of our services. So please take a look at that and start playing with the platform, because that's the quickest way to learn. So thank you very much. Thank you, Richard.
Thank you.
And we'll see you at the next session.